Hello engineers and welcome to Civil Nirman. Till now we have discussed 7 important structural components of pre-engineering building. If you haven't watched that video and if you are here for the first time, go and check out all the previous components. Now let's discuss the remaining components. So here is the 3D model. On number 8 we have framed opening for windows and louvers. Basically this opening is provided either for the windows and louvers. Louvers I have already discussed in the previous sessions, so I'm not going to discuss more in detail here. On number 9 we have end wall wind column. See, wind columns are used to transfer the end wall forces to the foundation or slab in buildings that cannot be braced by cables or lack enough sheeting to provide diaphragm strength. They are fixed base columns that require special concrete design in order to function properly. The number required per site depends upon the building width, height and design wind load. Also, end walls of pre-engineering buildings can be designed as both rigid frame and post and beam method. See, the post and beam end wall system consists of end wall columns that are called as posts with pin ends supporting end wall rafter. On number 10 we have roof bracings. As our component number 7, bracings I have already discussed, but let me give you a difference between the elevation and roof bracing. See, elevation bracing is installed in the vertical plane, typically between the columns, to resist the lateral forces such as wind or seismic loads, ensuring stability along the height of the structure. While plant bracing on the other hand is installed in the horizontal plane, usually between the beams or trusses, to provide stability and distribute load across the horizontal surfaces, maintaining the structural integrity in the floor or roof plane. On number 11 we have main frame rafter. See, a primary beam member supported on columns. Rafters are a series of sloped structural beams extending from one point of the ridge to the other point of hip and up till the wall or plate. On number 12 we have jack beam. See, the beam used to support another beam or rafter to eliminate a column support. Jack beams are used to make economical as well as safe approach for creating longer bay length when large unobstructed space is required. I have already made one video on jack beam, so you can check out that particular video on our channel. Also, its link is given in the description box. On number 13 we have main frame tapered column. See, column and rafter connection. This is as per choice of engineer and functional need of framing system. Column to rafter connection can be designed in various methods. In each option of rafter column design, there are different merits and demerits, as steel consumption also keep on varying in each option. Therefore, it is necessary for designers to opt for economical connection unless some functional constraints are there. As a standard practice, an ease of erection and the economic following priority is recommended. So let's see few of the typical column rafter design details. See, on number 1, this one is the straight column top mounted rafter. On number 2, tapered column top resting rafter. On number 3, reverse taper column top mounted. And on number 4, tapered column supermarket column. Now let me tell you one important thing. We can go for column rafter connection on side mounted also instead of top mounted in all above 4 options which I have shown you. Then on number 14 we have main frame fascia, then cantilever fascia frame. See, fascia we have already discussed, but let me give you a brief about the difference over here. See, a main frame fascia frame in PEB structure is an integral part of the primary structural system, providing support and stability to the building's main frame. Now, in contrast, a cantilever fascia frame extends outward from the main frame without additional ground support, typically used to create overhangs or extended roof lines for the aesthetic or the functional purpose. On number 15 we have lean-to. It's a slight different category. See, a lean-to building is originally defined as a building in which each rafter leans against the another existing building or wall. This type of frame is the most preferred type for shades requiring an expansion along the width. It requires the original shade to be designed such that it is able to take the load of the expanded shade along with the new shade. That means If you have planned for the future expansion, the existing shade should be designed considering that particular load. So lean-to shades are designed to match the roof slope of the existing shade such that the water is discharged out of the shade. On number 16, we have crane beam. See, in pre-engineering buildings, when a crane system is required, crane runway beams are required to support the crane system. Now see, complete system information of crane is required to design and estimate the same. Usually, pre-engineering building companies supply the crane girders because installing and aligning it throughout the length of the building requires special expertise. The crane runway beams or the gantry girders are simply supported built-up sections with or without cap channels and with maintenance platform and ladders. Usually, catwalks for crane maintenance are mounted alongside the crane beams. It can be suspended under the rigid frame rafters or elevated above the top of the building. So I hope you liked our way of teaching fundamentals of pre-engineering building components. Hope you like this video. Share this to all the beginners. Now if you want to check out and learn pre-engineering building in detail, you can check out the detailed course in the description box. Stay tuned for more such structural engineering updates. And remember, don't just learn software, learn concepts. Thank you.